Great.
We saw your screen.
Not yet. Give it a second. It's starting.
Yep, I will wait a bit. Just
The floor is yours, I think.
okay. So do you see my screen? Let me just quickly try to get rid of the bar.
Yes.
Okay, everyone sees my screen?
Yes.
Okay. Okay, thank you, Paul, for inviting me on the B-Weekly. And let me talk about what we are doing at FitBeauty regarding our OSLC infrastructure. So the topic of this talk in particular will be how you can make analysis tools more accessible using our OSLC-based service-oriented architecture. And you will see how we are also using Arrowhead for this purpose. So a bit of motivation. At Beauty, we are developing a lot of analysis tools, and the more we have, the more we are thinking about how many users can actually use these tools. It's not that these tools are bad or they are not useful. The main problem is that many of them are way too complex for average engineer to use. And it's very important to make the usage of these tools as simple as possible for these users. So we started with the motivation, questioning ourselves, isn't a tool no one uses in a way actually useless? Now we address this issue. We want to make these tools as easy to adopt and use as possible. And the approach which we are using is to transform these analysis tools into OSLC compliant web services, provide user-friendly clients that actually can work with such web services. And also, as you may imagine, the more tools you have, the more important is how you actually manage such tools. How do you discover which of these tools are available on your network and you can use them? How do you actually configure the clients to be able to interact with these tools and actually use them? Because each tool has a different interface. So we need to address all of these issues. And how we are addressing it? As for the transformation of the tools into web services, we provide the Unite tool. As for the user-friendly clients, we have the unique client currently for Eclipse or Java-based applications. And for the orchestration, mainly for the automatic discovery and client configuration, we use the Eclipse Arrowhead. So let's look briefly how the architecture actually looks like. So before we have maybe you all know the situation where you have a lot of analysis tools, you have your favorite IDE, you actually want to run the analysis from, but there is a lot of work in the middle actually on making it possible. And in many cases, it's still not as simple as the user would like it to be. So what we want to do is to move to the right part using our architecture when we take all the analysis tools and simply transform them into OSLC compliant web services. We also provide clients for IDEs that can interact with such services and interconnect everything together through the Eclipse Arrowhead. So that's our goal. Now let's look at each important part of this infrastructure in a bit more detail. So we'll start with Unite, which is the first part where you start. You have an analysis tool, or actually it can be any command line tool you have, and you want to transform it and provide it its functionality as a web service. So you have multiple ways how to do it. Well, you can always take the tool, install it on your laptop and use it there. But many of the users, we can actually talk from experience from Honeywell, they do not like it because many of these complex analysis tools are really complex to even install and configure properly. And if you are not using properly the tool, if you do not configure it properly, then in many cases, the results you get are not very beneficial for your cost. So the configuration is also very important, and you need usually the experts that do it for you. Okay, so if you have it on your machine, there is also the issue that it can easily overload your machine, eat all of your resources. Like some of the analysis which we do take hours to actually finish, and you do not want to work on your computer where the analysis tool is eating 100% of your CPU and all the memory from half of your workday. Of course, you can take the tools and offload them to the servers. The issue is how will the user interact with such servers? Taking aside the usual stuff like do you have even access to the servers from your IT? Is it secure for you to access the server? Aren't there some internal data you shouldn't actually see and so on? Well, you can always transform the analysis tools into a web service yourself and connect it with your custom client. But actually, it's a lot of work, and you need to know a thing or two about creating web services, which is not the case for many of the users that want to do it. So our ultimate goal is to provide you Unite, where you just fill several configuration files, and you already have a fully working generated OSLC compliant REST API for your tool, which you can immediately connect with various clients, be it basic REST client, a specialized client integrated in your favorite IDE, a custom-made web client, or a fairly configurable web client, or any other type of OSLC client you can potentially use. As we are supporting the OSLC automation specification, any client that also supports this specification can interact with such services and request the functionality from them. So I actually talk about most of the stuff on this slide. So let me just emphasize the green part, the most important part when you are using Unite, what that means. The transformation into the web service compared to the manual effort is almost for free. You do not need to modify the code of your tool. You do not need to modify the Unite tool itself. You do not need to be an expert in web services. You do not even need to know how they work. You just need to have an idea how the interface should look like, what kind of parameters from the tools should be exposed to the external users, and accordingly fill the configuration files to actually let Unite generate such interface for you. So if you look into more detail, how are the instructions are actually doing so, then you just need to do some work in the blue and green parts here. So after installing Unite and the analysis tool, you just need to create two configuration files. First is an automation plan, which actually describes how the interface should look like. And the second is a technical properties file, which just contains some specifics where the tool is located on your server and some machine-specific information. The green part is how you need to actually create your client to be able to interact with Unite. So when you want to execute the analysis, you need to transfer the input data, the SUT, system under test. We actually already support transferring the data in the base64 encoding or just instructing the adapter to fetch the data from a specific URL or fetch it from a Git repository. So you have multiple options already there. Then you can execute the analysis, which mainly boils down to sending a request to perform the analysis with some specific parameters for your tool. These parameters will be then automatically mapped from the OSLC interface to the call of the tool on the server side. And then the adapter will just collect the results produced by the tool and expose them back to the client. As OSLC is a pool technology, then it doesn't work that you send the request and wait for the results of the analysis to be sent back to you. It works that you are continuously polling the service and asking, are the results already available? Is the analysis complete? And when you think about it, the blue part actually is done by the tool provider or server administrator just once for every tool, and you are done. And the green part can be completely hidden from the users by a good client. Which gets me to a next part where we will look actually for the client part. But before that, let me just briefly mention that actually we already tested it on multiple analysis tools from well-known analysis tools such as Facebook Infer or Valgrind to even something as simple as grep. As we have Paul here, also Theta is transformed into such OSLC service. And we also have some experience with transforming various industrial in-house solutions, such as the Highlight tool, I will be briefly talking about in the end. So let's look at the client side. What do we provide here? We provide UNIC, which stands for Unite Client. It's residing here. It's integrated into the IDE. And actually, we have also first prototype for Visual Studio Code. But the Eclipse integrated UNIC is much more flexible and configurable as of now. Okay, so what is UNIC? As I mentioned, it's compatible with Eclipse. It's actually fully integrated into the Eclipse, but it can be used in the standalone Java applications if you want. We are also providing it as Maven packages. It's modular and extensible in a way that actually when you interact with Unite, you are doing it that the interaction is split into multiple tasks. You can see here below in the small illustration how the task can actually look like. So this is actually a sequence of tasks that tells the client how to interact with the Unite on the other side. And it usually comprises of 3 phases. The green part is just collect the inputs. The blue part is the interaction with the analysis tools, which, as I mentioned, boils down to registering the input files, the system under test. Then you perform the analysis, and then you get the results of the analysis back to the client. The last part, the red one, is mainly looking at how to process and visualize the results, because each tool may provide a fairly different kind of outputs. So you usually need specific tasks to process it and visualize it appropriately for the user in the UI. What is great is that UNIC comes with a lot of built-in configurable tasks. So most of the time, you just take what is already available and just configure it to your own needs. And you are done. You do not need to write anything yourself. But if you choose so, you can also write in Java your own task and register them in UNIC and then reference them in these task sequences if you want to. And these task sequences are actually how the clients are configured. And this configuration can either be fetched from a local directory, an update site from where the UNIC is usually installed from. So this is quite convenient. But the most convenient and most flexible method is actually using Eclipse Arrowhead for this purpose. So here is a very brief showcase. How does it look like from the client side to do the analysis? So when you use UNIC integrated in Eclipse, you just right-click on your concrete project, go to the tasks, choose the analysis that you want to perform, and after a while, you get the results, which are processed and visualized as Eclipse markers in Eclipse. So in this case, we were calling Facebook Infer, which is a static analyzer of Java or C code. In this case, it's Java code. And what we get as a result is a list of issues that were actually detected in your source code. And we link these issues to specific files and lines in these files where the issue was actually detected. And as you see here in the Hover window, you can see a detailed description of each of these issues which we found. Of course, different tools may handle the visualization and integration into the UI in a different way. For static analyzers, this is the most, let's say, expected behavior and visualization the users would expect. Okay, let's look at the last part, which is the integration with Eclipse Arrowhead. So we mainly use Eclipse Arrowhead for automatic discovery and configuration. And let me briefly show you on this animation for which purposes we can use it and what's the benefits for the user. So here you can see the part you previously saw in Eclipse. So we have the loaded task sequences, usually here in the empty window. And what we usually have as a situation is that on the network, we have multiple analysis tools available. And we want the client to be able to learn of their existence and be able to call them by a single click in the menu. So this kind of automation is what the user would like to have. How to do it with Eclipse Arrowhead is easy. We just deploy Eclipse Arrowhead and let all the tools, or actually especially the Unite here, to provide the configuration how to interact and use the tools. So we will actually push this configuration to the local Arrowhead cloud, and then the client will just connect to the cloud, fetch all the configuration, and provide the analysis tools directly to the user with a single click in the menu. Okay, so this is automatic configuration for clients, which the Arrowhead will give us. What are the other benefits? What about if you want to add more analysis tools on the fly? Well, actually, it's quite simple because you just take your tool, Unite, and the configuration, pack it into a single package, push the configuration you provided through Eclipse Arrowhead to your client, and you are done. And you can endlessly add more and more tools like that to your network, and all the clients will be aware of them. If you shut down some of the tools there and Unite with them, Unite will automatically deregister and instruct the clients, or actually the clients will be aware on each refresh that some tools were no longer there, and they will just remove them from the lists that are provided to the users. So inactive tool removal is automatically handled as well. If you want to add multiple instances, it's even simpler than adding a new tool because you can reuse most of the configuration and provide, for example, instances of your tools that are running on US or EMEA servers, which is, for example, a very important use case for big companies such as Honeywell, where our analysis tools often use third-party solutions which are licensed, and the licenses may be region locked. So we need to actually have multiple instances for multiple regions. But of course, it can also be very beneficial when you want to connect with the service that is the most responsive to your client because it's on the same region or maybe even on your same site as you are residing. When we look at it from the client side, if you want to add more clients, then actually you do not need to do anything at all because they will all connect to the Arrowhead, fetch all the configuration again, and all the currently available tools will be immediately visible to them. If, of course, you will not restrict the visibility through the Arrowhead authorization service, of course, which you can do. And this is another benefit of the Eclipse Arrowhead here. Okay, let me conclude the talk with talking a bit about what are our experience in using this infrastructure in practice, and what we already have beside this infrastructure regarding OSLC, and what we are already working on right now. So we mainly use the infrastructure in Honeywell for some time. We use it mainly for our in-house test vector generation tool Highlight, which is running on multiple servers for months with thousands of executions per month. And actually, we are currently deploying this infrastructure to one of the biggest platform projects which we now have in Honeywell. So it will be used even more extensively from now on. And we already have 4 different clients which serve different purposes. So the web UI is very convenient for users starting with our in-house tools, that instead of actually needing the users needed to install the tools locally, they just open a web UI, feed it with the input information, choose which server to handle the analysis, and they will just wait for the results. No specific knowledge of the tool, of this configuration, nothing is needed for the user. So it's very beneficial for onboarding new users to start using this tool quickly. FOREC is our complex analysis aggregation tool, which actually connects with multiple analysis tools, do the analysis of the same input using all of them, and then aggregates the output across these tools together. So we will get more interesting kinds of analysis when we, for example, merge multiple results, multiple errors detected by different tools together, and have the bigger picture of all the different errors which we can find there. We also have a PowerShell command line interface, which is currently used extensively in the CI/CD pipelines, where we can actually offload very complex tools to dedicated servers instead of requiring these tools to run where the, in our case, Bamboo agents are actually running. So this actually enabled us to provide the more analysis tools for the automated CI/CD pipeline test analysis in general. Not only testing, but also various kinds of early validation and verification techniques. And we also have the unique, which is similarly to the web UI, very convenient for especially the first-time users to be used. And it's also very good in validating the ease of use of new tools, because, as I mentioned, it's very flexible and configurable. If we wrap a new tool, the unique is the first tool to try the interaction with, because we can change very rapidly how the interaction should be done. We can fix it rapidly, and then when everything is stable and working, we can push the configuration through either Eclipse update site, or later we will use the Arrowhead now. So the advantages of OSLC is it's great that it's open source and it's a very rich integration technology. It's very flexible and extensible. We actually use the automation specification extended with the notion of SUT ourselves, and it works very well with even the clients that are not aware of the SUT extension, because they can still use the basics that are required there. However, the disadvantages are that actually the communication and the transfer of the data can be quite time-consuming, because mostly you are using XML to transfer the data, and transferring the data through base 64 encoding also increases the amount of data you're transferring. So actually, for file management repositories is not that great, but we are now experimenting with some OSLC interfaces for Git. And it's also not very good for a heavy event trigger traffic. However, for that, we can actually use Eclipse Arrowhead for this purpose. So it's kind of very synergetic technology to be used. Not only that we will be use it for the service discovery and configuration, but we can also use it for the event trigger traffic where OSLC is having a lot of issues. Currently, we have already several adapters and clients available in our OSLC ecosystem, as we call it. We have this architecture management adapter for EMF-based models. We tested it with Capella. We potentially can use it in the currently prepared European project with OBO. And actually, it's exposing the Capella models through SysML v2 OSLC interface, which is defined by the SysML v2 committee already. And a prototype of this domain is already publicly available. So we mapped the model into this domain. We have also a requirements management adapter for Jira, well, especially for the requirements for Jira extension, but it can work standalone with just the basic Jira as well, if you want to use it. Then we have now a JavaScript-based OSLC client, which you can use from a web client if you want to, which we want to actually use in the web UIs. And we also did some experimentation in visualizing Capella models in a web browser, actually by using the JavaScript OSLC client and the above architecture management adapter, and it was working quite well. So as a proof of concept, it validated that it's definitely possible to do so. As for the ongoing work, we are currently working on some improvements for the Unite client for VS Code, which is currently just a prototype. But we want to make it as modular and extensible as the Java implementation, the Unique, which I mentioned. We are also working on web-based Unite client that is kind of, providing a more abstract layer compared to the Swagger UI, because you already have a Swagger UI on the adapter side, but you still need for many requests provide this OSLC compliant document, XML document as a body. And we want to actually replace this need to with a simple form where the client will just ask the user, these are the parameters you need to provide. This kind of data are actually expected to be provided for these parameters. And here's the form where you fill everything up. You do not need to know anything about OSLC compliant documents to provide as a body. So this would simplify the creation of new web-based clients, not only for Unite, but for other purposes as well. We are also working on OSLC client for Python, as the current IOSLC, I think as they call it, is not that convenient for this purpose. Is mainly looking at how to use the Python on the server side, not that much on the client side, which we need more. So this should provide a similar functionality as the OSLC client we use from Eclipse Leo for the Java implementation. And as I mentioned, we are also looking at creating an OSLC interface for the Git. Okay, so this is everything from my side. And let me just conclude with a small demo of how everything is working with the Eclipse Arrowhead. So here you can see my Eclipse IDE, where I have several projects, and I actually have the Unique installed here, which you can actually see when you right-click on the shared, go to the tasks. Now you see that there is not only a list of the tasks, but you have the refresh task manual button here. You can also configure it to refresh periodically. For the purpose of the demo, it's not very convenient to wait, so we will just trigger it manually. So actually, you do not see any tasks here right now. If I trigger the manual refresh, and I will look back, what I see here, I have here analyzed with Facebook Infer Beauty server, which is actually a task sequence that is fetched from Eclipse update site. So it was installed as a Eclipse plugin, which contains the task sequence configuring the client. So without Arrowhead, I can actually already get the information through the update site. And when I actually start it, it will contact Facebook info running on one of the university servers. We will send the Java project, which I invoke the analysis on there, do the analysis. And as you can see now here, I got back a list of issues that were detected during the analysis. If I double click some of it, it will just move me to the editor, as you saw in the presentation. And I will see where the issue was actually detected. And here are some more detailed information about the issue that is detected here. So this works fine if you just, set up your analysis tools and you do not expect that they will be changing much over the course of their lifetime. But if you have a dynamically changing situation where you are adding and removing the analysis tools all the time, as we, for example, have in Honeywell, adding more instances, removing them, adding new tools we are experimenting with, and so on, then a better management than just pushing everything through the update site is in order. And this is where the Eclipse Arrowhead helps us. So let me just delete these errors here now. And what I do now, here you see that when I refreshed, I haven't seen anything else that the task sequence that was provided through the Eclipse update site. So now if I move here, which is SSH connection to one of the servers where I am running a different instance of Facebook info wrapped by Unite. And it's not running right now, so I will start it here. And this instance, this version of Unite is already compatible with Eclipse Arrowhead. Actually, it has a basic Eclipse Arrowhead client integrated inside. And when it starts, during the start of all the services, the web service interface, it also connects with Eclipse Arrowhead, the local cloud. It's configured there, and registers the task sequences and other configuration in Eclipse Arrowhead. Okay, so now everything is ready to go, as you see. And now when I go here, go to tasks and refresh the task once again, I haven't done anything else, just started the adapter on the server side. Here you can see, analyze with Facebook info, beauty server through Arrowhead. So this was automatically added by the adapter itself when it started. So when I actually execute this task, I will have practically the same results, and as we are currently running the same version of Infer on this instance as well. So I should have reported the same 4 error as before. Yes, I have them there, as I seen before. Okay, so you saw that I already, just by starting the adapter, I see it automatically into the client. And if I go back and kill it, it will shut down and refresh the tasks again. You see, it disappeared because now it's not running. I already killed the service, so I cannot actually request the analysis from such service anymore. Okay, so this concludes my small demo. When you see how we are using Eclipse Arrowhead, how it works in practice from the user perspective, we do not need to do any kind of configuration in Eclipse Arrowhead, just start or shut down the adapter, the server sites, and it will be dynamically projected into the list that the user sees in their clients. So thank you for attending the presentation, and I will be glad to answer any questions.
Thank you very much, Jan Feidor. You can stop the recording, but in the meantime, we can also have questions. Justina?
Thank you. Is it available for other languages?